Okay, let's take a look at our last section of polynomials for multiplication here. Special products. If I have a perfect square trinomial, it is the result of squaring a binomial. You're going to see that terminology a lot on standardized test. Perfect square trinomials. What in the world is that? It means you took a binomial, two terms, and you squared it. Exponent was the square. Here's your binomial. Let's say we take binomials with addition. So inside our binomial, we have addition happening. I have x plus 4 squared. Guess what? This is the FOIL method. This is just x plus 4 times x plus 4. Use FOIL or use what I call double distribution. X times x is x squared. X times positive 4, 4x. Let's do the second term. 4 times x, 4x. 4 times 4, positive 16. Combine like terms. This was probably one of our easiest things we've had to do after we just got done doing multiplying all those big polynomials. What if I have binomials with addition? And I'm going to take 3x plus 2y squared. Exact same thing. Double distribution. I'm just showing you another example. 3x times 3x. Maybe I need to show you 3x times 3x. Oh, that's not what I want. I want to do a line. Oh, I can't find, here it is, pencil. So sorry, so sorry. 3x times 3x is 9x squared. 3x times 2y is 6xy. Now all of a sudden I'm going to go to my second set of distributive property, 2y times 3x. 2 times 3 is 6. Y times x, yx. 2y times 2y, 2 times 2 is 4. Y times y, y squared. Combine like terms. 6xy plus 6xy is 12xy. And I am done. I suggest you pause the screen because I have an example here for you to try. R squared plus 5t squared. Take a moment, pause the screen, and do the example. Hopefully you all got this same answer. R to the fourth plus 10r squared t plus 25t squared. If not, please go back, pause the screen, and give yourself a chance to solve this problem. What about binomials with subtraction? Here I have a minus 5 squared. Again, we're going to use FOIL. You're going to just go ahead and you're going to do distribute, distribute. Sorry, I'm just trying to grab. I have a negative 5 times a. I have a negative 5 times a negative 5. I get all my terms. I combine like terms. A squared minus 5a minus 5a, I get a negative 10a. Negative 5 times negative 5 is 25. Here's another example. 4c minus 3d squared. 4c times 4c, 4c times negative 3d. Remember, the negative sign goes with the term. I'm ready to do my second distribution. Negative 3d, the sign goes with negative 3d times 4c. Oh, sorry about that. What a mess. Negative 3d times negative 3d. I have 16c squared minus 12cd minus 12cd plus 9d squared. Are you seeing a little pattern with these center numbers? Notice as we go along, the same thing that happened with the addition. We see a bit of a pattern on the two center values. I have one for you to try. So again, pause the screen. I suggest you use the double distributive property, otherwise known as FOIL, and go ahead and try to solve 2c minus d squared. Please pause your screen and attempt it. Hopefully we all got 4c squared minus 4cd plus d squared. If you didn't, go back and look at the two examples that I have above until you understand them. Difference of two squares. Huge words that you're going to find on standardized tests. The difference of two squares. All that means is that one was a positive, one was a negative. You're not actually squaring one of them. You're multiplying two binomials. Nothing's changing, everybody. You're still doing x times x, x times negative 6. X times x, x times negative 6. Look at those middle numbers. Their terms have a somewhat identical, but they are inverses because one was positive and one was negative. You can see here you had a positive, you had a negative. I can't believe I'm writing all over these slides. I hope you're able to bear with me while I do all that. I have a positive 6x. I have a negative 6x. They eliminated each other. They're gone. Gone. I'm left with x squared minus 36. The middle terms are eliminated. Try one. See how it goes and try it, okay? Go ahead and pause your screen while I get rid of that mess. Pause. And here's your answer. 49x squared minus 9. Wasn't that easy? That's it for special polynomials. Hope you enjoyed.